Hey, man, I'm so full. That pulled pork. You guys, you hear me okay? Do I have to adjust anything or we okay? Hi, Donald. Might be a little noisy. I'm printing spinners like crazy over here. So, um, yeah, I did rub it in. All the spices and stuff on the pulled pork. Um, yeah, so basically, I'll give a few minutes to let the guys kind of wander in. Um, but yeah, I bought a sous vide about 3 months ago, and I haven't really been using it too much. So lately I just went and got some recipes, and I've been trying them out, and yeah, it's been pretty good. I think I'm gonna keep doing it. Um, Last time I tried rib steak. Before that was bottom round. Bottom round roast um, was a little tough, and then this time I got the pork shoulder, and I've been trying to pull pork. Um, I think I need to put in brine and let it sit for a few days. I got to find room in the fridge to do that because it wasn't how to put it evenly salted throughout. So I think I have to deal with that. Anyway, let's give it one more minute before I start. The I did quite a bit of changes on the model, so I kind of want to go through them just so um, that we get to I get to show you guys what's been happening. I still have to update this particular model, but the all the ideas are there. So okay, let's start because I figured if they're not here by now. They'll get this. We do the review on the stream and then we go from there. Let me try to fix this a little. There you go. Let's try that. Okay, so let's zoom in a bit here and have a look. So the biggest change, I guess you guys already know, is I'm gonna try to fix this. It's kind of bugging me a bit. Yeah, there we go. I think that should work a little bit better. Um, so one of the biggest changes is the use of linear rails now. So before the model you guys saw before, I was trying to replicate the Ultimaker mechanics by using rods like they do, and then kind of cross rods. The problem with that was I wasn't able to the um, maintain the rule that I set for myself, which is to have the outside wall, outside slots for the enclosure. So what I did was I ended up um, using in the corners here using 60/60 extrusion, and what that allows me to do is actually reserve this outside slot here for the enclosure. That's going to run the entire length of the entire height of the printer, while giving me access to the inside slot for things like this linear rail mount. So um, that makes it a lot cleaner, I think. So um, and then the use of linear rails allows me to remove a lot of complexity in terms of printing and dealing with pulleys and dealing with multiple rods and the rod motion and stuff like that. So um, what the linear rail eliminates almost like more than half the parts count on what is needed to get the same movement. So let's say let me just kind of demonstrate that here. This still moves. These two still moves the same way, and the cross rods is still gonna basically. If you imagine I had modeled the spider, it would still be connected to the crossrods here, and it will still function the same way as how the Ultimaker moves, and all the weight is still going to be on the outside where it's heavily supported, and the weight of the moving parts is going to be kept at a minimum. But what this design allowed me to do is actually remove the need for the rod and that access the axle, and it removes a whole bunch of other stuff like rod mounts and stuff like that. I basically mount the linear rail on this extrusion and I'm done. The carriage rides on the rails, and then the cross rods will ride on one plastic piece that we will print to interface the rod to the linear rail carriage. One after this was sort of the very rough like proof of concept to make sure that my rod spacing and the movement of the carriage on the linear rails is still going to replicate the same movement as before. Then after that, I kind of had to think about how do I, without the axle that crosses the outside, the axis that basically runs the belt. How do I move the carriages? That was the next hurdle that we had to have to look at solving. So we'll get to that next. But one of the nice thing about linear rails sitting on this extrusion is that I'm able to do that. I'm able to get these two pretty close to the corner. I will show you guys. I need to leave about 50 millimeters here, 50 millimeters here, because we need to mount a motor in there. But otherwise, by having these carriages as close as possible to the corner, and these cross rods able to have almost the entire travel of this whole perimeter, we basically have managed to maximize the usable space inside of here. The old design, there was a lot of wasted space because I had to use some of the space for the XY rods and the belts, and then I had to figure out how to do the motor mounting and stuff like that. So it was really like a bit of what was really cumbersome and was really cluttered. So this, I think, simplifies it a lot. So what's missing here is the motor driven, right? So I was talking to Leslie, and one of the suggestions he had was we could wire the two motors in series and drive the same axes on both sides, and it should run with the same steps. So meaning that we don't need a fancy axle that transfers the power across and have all the drivetrain loss and the belt loss. Basically, the idea is that we're going to have one motor mounted on this side and one motor mounted on this side. That will drive this. That will drive this movement, and it's going to be wired in series to the same same stepper driver. So basically, it will have the same steps. And all we have to do is on this side is have an idler on both ends here that will return the belt to the motor. So that simplifies the design quite a bit, because I no longer have to worry about belts that cross and have to worry about belts that go over each other. I played around with a lot of iterations of the motor mounting, and I came up with a pretty simplified design, basically. So this is what I came up with, was basically using a 30 millimeter. Normally the steppers at the normal size NEMA 17 steppers are about 42. So I was able to find a compatible 32. I think this is 32 millimeter. It's not so much a pancake. I mean, pancake would still be smaller than this. It's kind of like mid-size stepper that I'm able to use in this base. And what that does is that actually this motor mount is not quite complete yet, but the motor mount will offset the motor in a way that and get a good shot here. There, there you go. That'll offset the motor in a way that this pulley is directly in line with the middle of the carriage. And on top of this piece here, I'm going to continue working on this. It's going to have the belt mount and the tensioner here that is going to basically loop the belt around. And so the way that the belt is going to run is the belt's going to run from here around the pulley into the belt mount here, and then the other end of the belt goes all the way around and comes back. So this motor is going to be it's going to be stationary here, and it's going to move this guy. I got to do the joint movement there, but you get the idea. It's going to move this guy up and down as well. This is exactly 15 millimeters from edge to edge. So I was thinking of using a 500 millimeter extrusion. So that gives us approximately 400. Actually, the 450 left over, but then we have to have 50 millimeter on the other side for the idler. So that gives us a complete 400 travel. So my rough calculation is basically that works out to about 380. So in theory, if I optimize it correctly, and if the spider is not too big, we should be able to get 350, 360 XY. So that's a little bit more than the 300 we were aiming for. I think nobody's going to complain about having a bigger area, right? So let's go back to the other drawing for a second. So what that means is that this from corner to corner is about 560 millimeters, so a little over half a meter cube. But that gives you 360, probably 400 tall. So it's quite a bit bigger than what we were shooting for before. But the cost of the linear rails and the fact that we're going to be using 10 mil for the cross rods allow us to increase the size of the printer without really having too much downside. So I figured, might as well go big, right? While we have it anyway, might as well go big on it. But with that motor mounting, we no longer need these guys. So it's going to be almost a straight shot all the way up to the top, and then basically you cover up the top and you slot some holes for the filament to feed through. And what we'll do is we'll mount the extruder in a way that is basically going to allow you to feed it into the print area with a Teflon tube, like a PPFE tube. So it's exciting. I think this works, and it's so much more simpler than the way we had it before. I mean, if you guys remember what we had before, was like it was a big mess of pots, right? So now we basically simplified the pots count quite a bit. Let's see. I wanted to show you guys what the linear rails look like. I met with Digus Wrap, and he sent me some samples. So this is what the linear rail and the carriage looks like, and I'll put up here. This is it. I'm moving it, and you can't hear anything. I'll move the screen out of the way just so that we get the full effect here. You hear a little bit of noise, but it's nowhere even near noticeable. So the carriage themselves, I mean, if you look at it, okay, they basically, there's actually no resistance on the carriage itself on the rails. The rails themselves are pretty sturdy. This is 12 mil rails. We're gonna go with 15 millimeters, so basically a little bit wider, and the carriage will be a little bit wider as well. You can see the, I guess, material, the non-friction material inside. Um, the one thing nice about these is that on this side, guys, I don't know if it focuses. You see there's two white screws. Those two white screws adjust the preload on the side and on the top of the carriage. So it's already adjusted from the factory, so there's not a lot of wiggle. But over time, as you wear this down, you're able to adjust that so that it compensates for any material loss in the carriage. And if it gets really bad, basically you just pop out the carriage and then you pop out the liner and then you can put it back on and you can reuse this. Um, if you look at high wind on YouTube, the high wind knockoffs that you get off AliExpress is nowhere near this smooth. So, um, yeah, this is basically what we're gonna go with. Um, you probably could get away with high wind, but I will try to find a sample and show you guys how much noisier it's gonna be if you use high wind. Um, I guess let's get the elephant out of the room, right? Um, hey, well, what the hell are you doing? You're on a cruise. Just go enjoy yourself. What are you on my stream for? Um, what was I talking about? Oh, yeah. The only downside to using, I guess, I mean, you guys have probably already guessed, is the initial cost. Um, the the carriage themselves, uh, roughly the 50 millimeter version of this was roughly $40. The rails was about $40, depending on the length and depending on the volume that we buy it at. So 4 rails at, let's say, we get a good price, let's say $75. So $300. I know it's a lot. 4 rails at 500 millimeter with the deluxe adjustable carriages, 3 bills, $300. So it is quite a bit. But if you look at high wind at 500 millimeter with some really shitty carriages that make a lot of noise, I think we're looking at 90 plus whatever the shipping was, like 140. So basically half, 130 and 40. Basically, you pay half for high wind, or you pay 300 for IGUS. So this part here, that adapts the 10 mil rod and attaches it to the carriage and the rail, and how the carriage attached to the rail. In theory, we could have two versions, right? We got the economical version of high wind, and basically you would try to get the geometry in the same spot, replace the rails with high wind or some compatible one, and just redo the adapter for the carriage. But like any other good um, design, the reference is going to be using IGUS. Basically, we'll have a reference design, and then we'll start deviations or alterations from there. But I want to make sure that at least we get the reference out of the way. The other thing is, if I bring up the prototype parts. Hi, John. So this is that piece I was talking about, that adapts the 10 mil rod onto the IGUS carriage. So I kind of want to talk about it because I know a lot of people are going to say, well, you spent a week on that, and they look at this and they think it's a very simple part. That's probably a problem that I want to kind of address, because it's not as simple as it looks. First of all, the problem is to get the placement of this rod hole and these in the right spot, get the overhang correct, and then on top of that, constantly thinking about the print orientation, because I mean, I had like before. I think I ran into this problem before, right? With the do I have it still? Yeah, I still. So, no, you guys remember the old characters that now is obsolete. I had so much problems with them because on the design they look great, they work great, but when you print them out, there's no good orientation to level it or to land or to sort of how we put it to ground them so that it's easy to print. I mean, I was doing all sorts of compromises, right? Like if I printed it face down with the support inside, it's gonna be crap. Then I get good counter bore holes on this side. If I put this side down, then the counter bores look like crap, but I get good bearing surface here. And also, it was complex because there's so many different ways that this thing is counter bore and all that. It was more complex than it needed to be, and the only reason I had to do it that way was because I'm trying to replicate the carriage from the Ultimaker. And I very early on I thought this doesn't work because I'm gonna inherit all the issues with this, and it's gonna be a pain in the ass to get people to print these correctly. So that's why now with these newer parts, you see that I took the effort. So basically, this will be the face that's gonna sit on the print surface. So it's basically gonna print like this. This hole here with the counter bore um, is I test printed this is able to make this hole pretty good. Um, in here we have the IGUS liner, so um, it doesn't have to be exact. It doesn't have to be perfectly smooth. And because this rod actually doesn't spin, we had this problem where that rod had to spin when it was used as an axle. So put the part back. So I had to put bushings in here so that the rod would go through here and spin, right? But I don't have to do that anymore because I'm using linear rails. So um, this hole doesn't have to be exact. All I have to do is make this. I'm able to accept the bushing without compressing it, and the rod will sit in here on this in the shelf. The bushing is going to keep it in alignment, and that's it. The the top surface of this, there's going to be another piece that sits on top of this that utilizes these mounting holes to join the two pieces together. So basically, the belt holder and tensioner is going to be a separate printed piece. That's going to have its own flat surface that's going to sit on the bed. And basically, we put that piece on top of here. We use 4 bolts that bolt through the two pieces into the linear rail carriage. So, because I could have easily modeled a belt holder on top of the surface here, right? And that would look great on here, but then I end up having to use this as the surface that sits on the print bed, right? Because otherwise I can't. Yeah, that would be the way it looks, and then otherwise I can't. If I have something here, I can't make this the flat surface. So um, that was a lot of consideration that went into this. I guess that's what I'm trying to say. It's not as easy as it looks when you go through. This is like you can tell this is version 12 of this particular mount. I mean, I took a lot of effort in this as well. So the other one that we were looking at before was the motor mount. This is another piece that, again, people can look at it and say, you spent that much time on this piece? Well, again, it's not as simple as it looks because, again, I had to think about the print orientation. So the print orientation would be like so. Well, you can imagine if I somehow make this flat. This side is down, and these, I guess Pat is calling these hookable alignment blocks. It's gonna print fine. It's gonna print fine because it's only 1 millimeter. If I could zoom in, it's only 1 millimeter here, and there's gonna be slight out affecting here because it's not supported. But I think I have it here somewhere. It doesn't affect the piece. That's the great thing about it. I think I have it in a second. Yeah. So this piece is has 1 millimeter hookable holes, and it just slight sagging here and slight sagging here, like literally like you don't even see it. Like that's how good it is. So it sat on the bed like this, and it printed this in midair and printed this in midair. So we're fine with that design. So again, a lot of thought has to go into this piece, right? Where how do we make this printable so that it sits on a bed correctly. The other thing is using a lot of radius corners, right? Or fillets, right? Because what I found was that when I did fillets like this, I got to fillet this as well. Got to do that, but I'm gonna do that later. Um, when we were printing these on the Haribo, um, having rounded curvatures like this around these corners allow the print to go smoothly around corners, um, and it just makes it a little bit more. It also makes it stronger. Like the inner surface is here where it goes from one surface to the other. You end up with the you end up with a I'm not trying to pronounce this word gradation or gradient of transition from the horizontal to the vertical versus having a sharp corner, which you only have one um, one line of filament that transitions you, whereas this is more like a gradual slope that transitions it. So um, yeah, and the bottom, yeah, that's it too. The if I this is the bottom surface. So this allows you to also hide the elephant feet that you have, and also allows you have somewhere to stick a tool into it to lift it off the print bed. So so far these two parts is new for this week. This whole idea about this driven axes here with the linear rails is new. Um, this bolt here is basically 16, 14. I can look at it now. Jeez. Um, Give me a second. 12. So this this is fully countersunk into the surface here because I wanted to make sure the belt doesn't hit it, and also there's gonna be something here. I'll surprise you guys later. Um, this one is only countersunk by oh, I gotta fix that. That doesn't look good at all. It's only countersunk by 3 millimeter because this back wall here is only 5 millimeters. So I can only go down 3 millimeter there and have 3 millimeter of meat here for it to to kind of get a brace, because most of the weight is going to be on this piece here. It's going to keep that in constant, in the same position. This vertical is just kind of helper. It braces it against the vertical. So we're good with this setup. So this 12 and 10 mil M6, and again we went to a 30 to 32 millimeter stepper motor there. So let's see. While I'm in the directory, I can show you guys how I work right now. So basically, what I've been doing is in the main directory is basically all the work in progress that I'm still working on or thinking about, and it's not really finalized or close to being finalized. they stay on the root directory so that it's easy for me to find them. Then as they sort of get to prototype stage, I move them into prototype parts. So these are pretty much stabilized versions of the printed parts themselves. So I think I opened this one for you guys before. So basically, this is what the printed parts look like, and then from there, what I do is I assemble them into sub-assemblies. Um, the sub-assemblies are basically, let's say if I take the XY carriage here, basically what I do is I insert that printed piece as the base. Then I insert all the other parts, like in this case I inserted the IGUS bushing, which is why you guys see that the 10 milliwatts is on this shelf and also on here, so that should hope like that will eliminate any of the inconsistency in the print. It's going to give a smooth surface here for it to get and this shelf here is slightly smaller by 0.1, so this is compensating for any defects. So most of the time it's going to sit on the reference surface, which is IGUS bushing here. Then I have precision these holes against the coals in the carriage so that basically this is ready to go. The reason I do this is because I also made this into a rigid group, so they all move in one spot. And what that allows me to do is when I place this whole assembly, sub-assembly as a component on the drawing, I'm able to just very rapidly make a slider joint, and this whole piece, just because it's a rigid group, we move together. So I was finding that I was doing that motion over and over again. Like if I had to put this 4 times across all 4 rails, I would have to do that motion 4 times. But by having it as a subcomponent, I'm able to just add it into the drawing once, and I can replicate that over and over again in all 4 places. Like you see here, I actually, let's go back to that sub-assembly. The other thing I did is I layered them too, right? So the other thing I did is I took the extrusion, I inserted it as the base, I added the rails, then I took the time to actually insert each one of these M3s and connected them to a T-nut all through down the entire length of this rail. And then on top of that, I made this a sliding joint, so I should be able to. Oh, it's not. I need to ground something. This one. I need to ground this one. So I made a ground this one, and I could now slide this. So this motion again is I define this once, and when I use it on all 4 corners, this motion is done once, and the same with the limits. I set the limits, the travel limits, that gets inherited in all 4, and if I make any changes here, again it gets reflected in all 4. The only gotcha is it also inherits this grounding. So if I grounded this this rail inside this component and I save it, when I put it into the drawing that I'm using it in, I can't move it because it inherits the grounding of the rail to that position. So I won't save this because it's going to mess me up, but I didn't know that the first time, and then I inserted the component and it got stuck, and I couldn't move the component the way it needed to go because it was grounded. So that's something that might get you guys if you guys do have that problem later. So I kind of promised to tell you guys how I was kind of how my workflow was going, so that's how I do it. So in this case, you see that XY axis, the entire assembly that we were just looking at with the carriage and the M3 bolt and the extrusion, gets dropped in here as one piece, and I move it into the spot. I move that in the spot. Same with the other. Like later on, I moved the other two. Like these two, I moved in the spots. And once I did that, I inserted the crossrods, and I manually in here I manually grounded all of these rails, and the motion's there. It gets inherited from when I defined it. I had to rigid group this carriage, this rod, and the one opposite to get this motion. Let's see, got that. To get this motion, all I have to do is ground the. What do I have a screw there? That's weird. Okay, I'll gotta fix that. But by making this carriage, this rod, and this carriage as a rigid group, and because these two are constrained to this rail, it defines this movement. Pretty cool. Huh? So once I had the spider in here, if joining these two rods, moving a spider along this rail, or this axis is basically the same as before, which was remove the outside as well. So to recap, we're gonna basically have a. Oh, I see what I did. I moved that stupid screw out of the way. And just moved it. There you go. We're basically gonna have a motor here, a motor here, and then a motor here and a motor here on four corners. And basically they will move, but one pair of motor will move this, and one pair of motor will move this for the XY. And that eliminates me having to run axles, running belts, and running pulleys. The entire thing is basically going to be one pulley on the motor moving the carriage. Idler on this side returns the belt back to the motor, and we're ready to go. Like everything is self-contained inside of this envelope here. There's no, like, this is independent. The only interface to the outside is going to be this rod interface here. That makes it easy. We built the drivetrain outside on the table, making sure that it works. We guys can even do movement tests and so on before we bolt it into this chassis. It's gonna be so much easier because then, like, you could do your belt tensioning and all the other jazz off the chassis, and it's just gonna make the assembly so much easier. The only concern I had was, which I guess people are gonna bring up later, is 60/60. So with this 60/60, we're gonna have to through-hole this whole thing here and have like a 670, probably a 70 or 80 M8 across here. The only other thing we could do is, which is, you guys know that I don't like to do, is brackets. I hate brackets, and I don't want to use brackets. Or we could use blind joints. Blind joints means that there's a rod that goes into the cross piece, and then there's a T-net shaped thing here, and then there's going to be access hole on the side here where you turn it. It works like the IKEA furniture. You slide it into place. You turn a screw, and it pulls it towards the edge. Only problem with that is if you have to drill those access holes if you don't get it from Misumi. The hardware itself is not cheap either, so you might have issues with procuring that hardware. So I'm not sure where we're gonna go. So if you were in the camp like me, who doesn't need an enclosure, in this corner you get away with a 30/30 because the only reason it's a 60/60 is because I need the outside channels, right, for the walls of the enclosure. If you're not going to do an enclosure, you don't need the 60-60. You could go with a 30-30 in the corner. So um, that is something that we're going to have to think about, is because if we sort of drop that rule about keeping this channel open for the sliding walls and sort of kind of revert back to the idea of using bolts through this hole here to hold the walls, which is not ideal, then it's give and take. We could go back and forth on that. So really depends. I don't know. Like, I don't know what the consensus is going to be. So that's going to be interesting to see where we end up. Let's see. Let's go back to here. Oh yeah. So I think you guys probably seen me asking about the rod spacing on the Ultimaker. So this is not my design. I got this off of Thinkiverse. But one thing I noticed is that this is one of the crosswise holes, and if I get this one, okay, that's a good. This crosswise hole and this crosswise hole works for me. It's exactly where I need them to be. I don't need to do any work. I could basically just use this as is and inherit this part. I have to check the licensing, but basically, if I look at this, this is no, I didn't, unfortunately. Let me go grab this. Where am I here? There you go. So this hole here is 12 millimeters. My Igus bushing, it's 12 millimeters, and it brings it down to 10 millimeter. So in theory, if I get the rod spacing between here and here correct, exactly the same as what's on the Ultimaker, it opens up a whole new world, because that means that I don't have to worry about the spider. We'll grab a Ultimaker spider and slap it on the machine and off you go. The Olsen block, all those things that is great with the Ultimaker, bam, you have it. Like, you could use it. So if I could get that working, I think that would be best, because this one is a E3D mount for the Ultimaker. Man, I'm not rotating correctly today. And it's very, very light, and it's very, very simple. So having this on the spider is going to be awesome. If this is going to work, it's going to be awesome. So I'm hoping that I'm able to get the rod spacing. Waiting for Fish. I think when Fish gets back from his van life and to check on these Ultimaker for me, I'll make that judgment call to say keep those rods at the same distance. Because for me, it's easy, right? On the model here, these two rods, like if I do this and this is 20 millimeter distance. If I was to look at this, I think this and this, if I look at this correctly, is 6. So I'm not sure, because that's 6 on the edge. So on a 12 millimeter hole, that is 18, right? So 18. The distance between those two is 18. So I need basically, I'm off by 2 mil. I need to know if it's 18 or 20. If it's 20, I mean, if it's 18 and it's confirmed Ultimaker uses 18 spacing between those two rods, we're golden. I lower one of the extrusions by 2 millimeter, and we don't have to do any spider work. Like it's all done. We were able to inherit any of the models that we have on Thingiverse, or we could pick one off of AliExpress. So that's gonna be exciting if we could do that, because that saves a lot of time. Yeah. Like there's already 4 extrusion and 2 extrusion spiders for the Ultimaker. We could use that. There's holes for the wiring and the fan mount. Everything is already done. So that will propel the project a lot further, because we don't have to do any of that work. So let's kind of go and have a look. Bring up. I'll see if I could bring this one. That's good. Find the spider and show you guys. So there you go. So basically, that we're taking advantage of the fact that the outer diameter of the LM8UU is 12 mil. So, and then the advantage of the IGES bushing, the OD being 12 mil, we're able to put in a 10 mil rod in here and here, and basically reuse the extruder assembly from the Ultimaker. That this one is sort of kind of like the plastic uh, stock style, or we go with like a all metal one like this. Um, the all metal one like this is nice because like um, it gives you the mount for E3E, and it still works because these are still going to be 12 mil, uh, 12 mil ID, so OD here, and a 12 mil OD here. It's still going to allow you to put in those IGES bushings to adapt it to 10 mil rod. So uh, basically, there's a lot of possibilities. I mean, this one is fairly nice. It's $60. It's a little pricey. This one was 28. Uses Olsen block. This is basically going to be single extrusion. Right. So what else? There was one I saw before that was pretty nice. I didn't find it now. Yeah. So again, we eliminated like 3/4 of the belt and the axles that we needed. So that's kind of cool. Just changing it up. There we go. That one. That's the one I was looking at. A complete set, including fans, the all the wiring, the bolting tubes, all the screws, the ozone block, all the hot end, $88, $87.98. So there was another one. I'm trying to find it now. That's one thing about shopping on AliExpress is there's a lot of crap you have to go through to figure out where you need to be. There we go. That's the one. Same thing here. Um, for extrusion, like this is for quad extrusion. Same rod spacing. So I wanted to buy one just to see the rod spacing between these two holes, if they're 18 millimeter, and then if they are, then really I'm shocked at the fact that we kind of stumble upon this, and we don't have to deal with this spider issue. It's gonna be cool. Because I know that there's maybe I can search for it. There's a volcano, a dual volcano for Ultimaker, so um, that's probably what we should look for. Oh, there we go. Yeah, this is the one I was looking at. The whole top side here is aluminum, dual extrusion into volcanoes. This was one that we were laughing about in the chat was the the way they ran these wires is just crazy. Like talk about like zero airflow here, right? Like they totally blocked it off. I guess you would sort of run it around. They just sort of slapped it on there, but that's still volcano on Chimera block. So that and then the signature dual fan for the power the pot cooling, right? So this one is like 98, 93, 98. So again, it's one of those like basically I think if we budget $100 for the entire assembly, we're good to go. So let me think about what else to cover. Um, Tenucat. Um, Controller. So I was looking at this morning, and this one X5 Mini. So John pointed out that this one comes with four steppers. The larger folder this. Basically, this is probably going to be the one for the single extrusion reference build. Four steppers, um Ethernet, no Wi-Fi. Wi-Fi is optional, I think, on this. But it has basically it's 32-bit smoothie compatible. Um, 113. So I think the reason I was mentioning it was $200 before was I was also adding in the cost of the LCD, because the LCD is actually probably one of the best ones you could buy in the market. It is very expensive if you compare it to the cheap, you know, to 2004 or 2014, whatever that one model number is that we use for the Haribo. But like this one, the Vicky 2. If you look at this is a gorgeous display. Um, this knob, I have tried this knob. It's so good, and it lights up blue when the temperature is being cooled down. So basically, meaning when the hot end or the heat bed is not being heated, it's blue. It turns red when something's being heated. So at a glance, you can tell what is happening. Reset buttons on this side, so you can't fat thumb it and reset like how we could do on ours. SD card, mini SD card. Sorry, this is a micro SD card slot in the front. In orientation that makes sense. You insert it and off you go. Full graphics display. Nice, Patrick. See, this is red, so it's heating up. So it gives you that option. They have the STL for the stand, or you could basically integrate this into the like build an enclosure and make a mount for the 3030. You off you go. The board itself, I mean, is a work of art. Like this thing is nice. But $75. I think we were looking at the LCD for the Haribo was like less than $10. Like it was like something stupid like $7-8 shipped. So for 10 of those, you buy one of these. So it's really sort of up to you guys. So what they do sell is this for $1.50. You could buy a cabling kit that they sell that allows you to use the cheap AliExpress graphics display with any of the controllers. It's $1.50. You could go with a $10 or $12 display, save you $50. So this would be sort of the economy build if you don't want to use the fancy one, right? So this one will allow you to use the cheaper graphic LCD display that you get with the RAMs. Um, One of the other options that we was looking at getting was um, Rearm. This is basically the idea behind Rearm is you already have a RAM port. You're gonna basically replace your Arduino with a Rearm, slap your RAM port on top, and you have a smoothie 32-bit smoothie compatible RAMs powered board. The only problem with this um, is because it has to work with legacy hardware, it's very limited. You lose a lot of functions. Like you don't have, I don't think you could get Ethernet on here. There's no Wi-Fi. Um, the you lose the ability to use digital pods. So in the old days, when you want to adjust the power of the steppers, if you don't have a compatible board, like Rambo Mini has a compatible digipod, so they allow you to, like, that's why we were able to use low power, high power. But the old-fashioned Rams board didn't have that digipod, so you have to manually use a little screwdriver to turn the pod on each one of these. So with the Rearm, you lose the digipod capability. With any of the other ones, like the X5 Mini and the GT, they support digipod, so you don't have to deal with something wrong with their server today for some reason. I think that one of their low balance machines is offline, but it allows you to use their version of the digipod drivers and in smoother way control the power. So, and by the time you add in the cost of the Rearm, the cost of the steppers, and then the cost of a good RAMs board, you are the same territory as a Mini. So unless you already have, like X5 Mini is 113, I think if I price it out, to get all the drivers and all the RAMs and everything, you're looking at $90. So you are 20 something dollars off a full-fledged 32-bit board anyway. So unless you really after $20, is might as well just go with the Mini. The X5 GT, which I'm hoping if I refresh it, it'll give me the right server. Um, yeah, so one of their servers is down because it's obvious. GT version of the same idea basically gives you one more, what do they call it? Gives you one more drive stepper, 5 versus 4, but then you lose your Ethernet. You have to get the Ethernet on a separate module. What you gain is the ability to use Bigfoot drivers. So I think they were showing them here. These are what they call Bigfoot drivers. So they have more power handling. So the GT version is really meant for beefier motors, or you're going to use a CNC application. So by the time you add in your Ethernet and all the other jazz, it's about $40 more for the GT version, because you also have to buy another stepper. The reason why I mentioned the 5 stepper is because we are looking at dual extrusion. So you need two extruder motors. The Mini only has 4, so 3 for the axes, and then you have 1 left for the extruder. So you can't do dual extrusion. You have the same sort of problem as as the Rambo, where you only have 4, right? So have to go with 5 for dual extrusion. So first step is get the Mini working single extrusion. Then the next step from that is to go with dual extrusion. So I ordered both boards just so that I don't have to pay shipping twice, and I'm gonna have a look at it. I think Pat is also working on it with his X5, and then I think he's also got a cheapo knockoff from China, so we could play with that too. The nice thing about it is that it's the same firmware, different configuration file. So we can have different boards and it's the same version of the firmware, and we basically drop in different configuration files for different boards, and we have that on GitHub so that you pick the right one. So that's that. I think that wraps up most of the updates. Um, oh, the next shipment of the MK42 clones next week, next Wednesday or Thursday. They'll get shipped. So by the weekend, I should have them up in the store. I changed the pricing a bit. It was $95. It was $95 for the board, including shipping, anywhere in the world, and it was sort of a mistake. I mean, we were losing our shirt on it because um, the the shipping just killed us. So we restructured it a bit. So what's going to happen is for the next few, at least for the next batch. Let's say this call for the next batch. We are going to go with U.S. and Canada only for the next batch. I broke out the price as well. So now the board is uh, $80. If I remember, it was $80 now for the board, but you have to pay shipping. So shipping was 15 or 20, depending on where you are, and if it's Canada, US. So it adds up to be the same as what it was before, but it gave more transparency to where the money's going, because a lot of people are asking, why is it $90? Why is it $95? Like, where's the money going? And if I book it out where I tell you it's $80 for the board and 15-20 bucks for shipping, you know where the money's going. Like, I'm not trying to cloud the issue here. So I think that works, and I'm gonna leave it at that. Um, I did the same thing with the printed parts as well. So the Haribo, I am selling printed parts for it to sort of fund the project. So if you or you know somebody who wants to buy a Haribo but don't want to print it themselves, I'm selling them at the store. Um, the whole set, including everything, all the parts you would need. Just hit me up with your color choice, and I'll get it printed. On the two printers, it takes me about 2 days to get a set out. So let me know if you need that printed. Um, yeah, Donald, I think we're making pretty good progress. I think if I finish the idler and I start ordering the machinery parts and talk to the IGES rep, um, yeah, actually I got to get to that. I'll get to that in a second. Why? And I get some of these samples made and kind of get the movement going. And I'm hoping to get the gantry all working and send that up to Patrick to have him finish up the firmware testing. Then I'll go and work on the Z platform and get that all sorted out, because I originally planned for 300 by 300, so I got a 300 by 300 bed. A few of them actually. Like I think I started with 200 by 200, 5 of them, because they were cheap on shipping on 5. Went up to 300 by 300, got 5 of those, and now I think we are probably up to 380, 370, 380. I had to get new beds, so I'm not gonna order anything until we finalize the gantry movement. I'm gonna let Patrick play around with it and figure out all the movements and sort out all the firmware issues. Then I'll work on the Z platform and the movement there, because I'm pretty sure that something's gonna give there. I need to change something because um, it's gonna be different. So I'm gonna have to deal with that. Um, but end of June for first alpha, it is looking bright. I think it is on track, which is I'm happy about. I mean, we were shooting for end of June for first alpha. I think that works. So happy. Um, you guys know I've been using IGES for a very long time, and I finally met the one of the reps for the linear guy product group. He came out and met up with me at the coffee shop, and he was talking to me about the printers and stuff like that. Gave me some samples, offered his assistants and his engineers to say, basically, if I have any questions about which one to use, um, design like simulations and stuff like that. To just reach out to them and send them my design, and they'll have a review on the usage of the pod, and they'll offer their insistence on like figure out the cantilever forces and stuff like that. So it was good. I mean, I should have reached out to them earlier, but like I was just talking to the sales guy a lot. But now I'm actually talking to a it's kind of like a product manager or support guy. So that should bring some clarity into the situation. I had to order some more IGUS because the 8 mil um, the 8 mil bushings I got, I had to return those because I'm now using 10 mil. So I'm debating, right? Because um, there's a lot of stuff that like uh, I got that I probably could have returned back to them, but then I'm pretty sure I could use them for something. So I'm torn between the two. Um, the last few things, things we're coming up to a little over an hour. So last few things, I'm printing the spinners like crazy for the last few days because I got a few orders for them and got some guys at the store wanted to carry them, so I'm printing them out to sell. So it's going to be taking up some of my time. The other thing is, um, I think there's some improvements to be made on the original Haribo 3030. Um, I've been hearing a lot of people having issues with binding on the IGUS, and since I have some extra IGUS bushings anyway, I'm thinking about going back and doing some new mountings and new XMs to utilize those. So that'll give me a chance to kind of take a break away from always thinking about the cube. Um, Probably this weekend. I'll probably try to see if I can squeeze a day this weekend and get some Haribo 3030 um, mods, I would call them, out there. The only difference is that these mods is going to be 100% original, so they are not going on GitHub. I don't want people, who stealing the files again and then claiming credit on it. So those files will be available on Mattermost, and I will send those out to whoever asks for them. But the only thing I ask is that don't spread them. Just use it for yourself. Um, Not being petty, but I just don't like it. Like if you look at the last few weeks, what's been happening is everybody in Border has been taking those files and then putting them behind paywalls and claiming credit. I'm just getting a little sick of that. Not giving back. I mean, if they took the design and messed with it and then came back and did pull requests, I really have no issues with it. But it's just the fact that they don't that drives me up the wall. So. Um, but those mods are needed, so I'm gonna do them anyway, and then share them with you guys. I think that's it. I mean, like I said, I like to keep these an hour, so that it's not too long for people to review. And I apologize again for Saturday night not streaming. I wasn't feeling well, and there wasn't a lot of time, so I didn't stream on Saturday. Sorry to the European guys. I will stream this Saturday, noon, a little before noon. Let's say 11:30, just so that it's not like right at dinner time. I'll catch everybody at 11:30 on Saturday. Hopefully, next few days I will finish up that driven axes and with the idler and everything. Then if I'm able to order the parts next week, we should have something physical that you can see moving. So hopefully that works. Um, it's 8:30. I should go get going. Thanks for tuning in. I will catch you guys later.